Okay, so now we are going to do the 12 concepts or 12 heuristics. Okay. Okay. Okay, so the easiest one is to go by this flow called the keyword concept method. Why is it important? Because we need to first tell the child what he can see. So this will be okay. Keyword and draw an eye to remind the kid what he can see. Okay. Then next is by concept. So concept means more than, less than, same difference, same one, same total, and so on and so forth. So concept is like the what should I draw for concept? Okay, maybe we just leave it as this first. Okay, then next we have method. Okay, method. Okay, so method, maybe we can draw a pencil. To tell the kid what he can write. So maybe concept, we can draw a head. Okay, so, or okay, can draw a light bulb. Light bulb as in what the child can think of. Okay. All right. Okay, so here goes. Okay, first one, we have more than, less than. So when you see more or less than, the concept is just more, less than. So the method is a staircase or a gun or water gun. So if you want to make it more impressive for the kid, you can add in some shadows. Okay. Okay, next. Two ifs. If you see ifs, blah, 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 then you see how many each. then it end off with blah blah blah. Then need some more or left. Okay, so how do you type this? Okay, done. This is a two. This two if question or two if question. Then you use the 3-step. Your small difference. And that's your minus. Then your step 2, total needed. Then your step 3, step 2 over step 1. Then solve with first if, check with second if. Okay. Okay. So which is your first if? First if. This is your first if. This is your second if. Okay. Okay, next. Is your fraction or fractions. So for example, fraction of another fraction. Okay, one fraction of another fraction. And this one has units like kg, meter, liters, and so on and so forth. So this is called fraction of fraction. So your of is actually a times. This is a times. Okay, so this is a times. Okay. Okay. Okay, let's move on. Okay, then next we have the equal concept. So when you see, okay, so same thing when you see keyword, when you see the keyword equal or same, the concept is actually the concept is actually equal concept. So you can see that the keyword is similar to the concept name to make it easy for you. Then the method, which is what you have to start drawing. You have to draw two equal bars, or we can say that it's KitKat. Okay, KitKat, brown. Okay, KitKat. Okay, next. Okay, one note for this is like, for example, they will say that both John and Peter have same number of marbles. So what this means is what they have as a whole is the same. Okay. Okay, next. Then we have equal before change. So technically is they have same at first, or what they have is equal at first. Okay. So they have what you see is equal or same at first. So this is equal, same before change. So what you can do is you just draw two equal bars again. Okay, two equal bars again. Then if they says what they have after the change is the same, so equal same after the change is the same. Okay, so this is so what you can draw is you can draw them first. Then after that, you make them the same. So for this one, it's the reverse. You draw equal, the same. Then after that, you extend. You draw a gun or water pistol. So it's the reverse. Okay, it's the reverse. Okay. Then next, okay, so all these are whole. Yeah, again, what they have that's equal is the whole part, as in the whole piece. Okay, then next you have the equal fractions. So what you see is one fraction over here of blah 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 is equal to or same as. So this is called equal fractions. Okay, hold on. Okay, so we have a fraction here or something equals to or same as the fraction of another thing. So this is actually equal fractions. And what you can use is the tic-tac-toe, and you make it the same. Okay. Okay, let me make it big enough. Same. Okay. And this one is actually parts. Okay. And the rest is whole. That's why you make the... Okay, so for the whole, right, you have to make denominator the same. Same. Okay. Okay, but generally you don't need this method for these two. It's only for the first one. Then for equal fractions, you have to make numerators the same. So take note of the difference. This is numerators. Okay, a bit cramped here, but I want to squeeze all the equal concepts into one page so that it's easy for you to revise. Okay. Oh, there's still some more. Okay, next. We have the a same one. Okay, so for the same one, you see two objects. Okay, so you see two objects, keyword, and then one change. So this is called same one. So this is the concept. Then the layout for this will be okay, this will be okay, this will be object one, object two, your B, C, A table, your ratio, your change for the object that has its quantity changed, and then the new ratio. So this one must be made the same. Okay, next. Two objects, equal change. You see the word equal change or same change. This one will be under same difference. So same thing is a BCA table. Two objects, The third column is difference. So you have all the ratio and the difference, equal change, and then the final ratio plus the difference. These two must be made the same. Okay. Sometimes, if it's a model method, please add the change in front, or you cut from the front. Okay, you cut from the front. Add, cut. Okay. Okay, next, what about same total? Okay, before I move on, this one can also be age question, okay? Age question. Age. Or you can, okay, before I write age, okay, or plus, example, plus 8 plus 8, or minus 12 minus 12, okay? Or age related question. Okay, next, what about same total? Okay, two objects, internal transfer. Or minus 2 plus 2 minus 8 plus 8. So this is under same total. So this is a BCA table as well. So you have object 1, object 2. This is your total. So you have the BCA. Add up the total. Put the change, final ratio. Add up as well. Same. Okay. Okay, there's still some more. Guess and check. Okay, so what do you see? Two objects. And you know you have your average, or say if there are two animals, you know that both of them have different number of legs. Okay, two individual quantity. That means let's say if it's a dog, you know that it has 4 legs, and it's a duck, it has 2 legs. Okay. Then you have the actual total. Okay, so there are a few things that you must take note. There is no percentage ratio fraction. There is no more less than. There is no every, which is grouping. Okay, there's no equal. Okay, so in fact, you can use the keywords that are related to other concepts to check. Okay, so this is question check. And then you have your step 1, assume or opposite. So if they want cats, you assume all are ducks. If they want chickens, you assume all are cows. Big difference. Then you have your small difference. Then you have your step 2 over step 1, step 3. Okay. Okay, so how kids remember this one? This one is like a big tortoise. This is your big tortoise. And big tortoise over small tortoise. Okay, so it's big over small or big bully small. Okay. Okay, next will be grouping. Okay, for grouping, you see the word every. Sometimes each. So this is grouping. Okay, this is grouping. So for grouping, there are 3 steps. You need to know what is in one group. Then you need to find your group value. And for your group value, normally we look for 2. And then for your step 3 is to find the number of groups. Which is your total value divided by your group value. And this is given. Okay? So that's grouping. Okay, still have or not? Still have, yeah. That's why memorizing all this is so important. It will actually give you an edge over others who didn't memorize. Okay. Hang in there. A repeated. No, okay. Okay lah, repeated identity lah. Okay. Repeated. This is simple. Identity. Oh, we still have a few more. Okay. Name 1, name 2, name 2, name 3. RI. Okay. So you have name 1 is to name 2 is to name 3. Write the ratio. Write the ratio. This must be made the same. Okay. Okay, next. There's another type. Yeah. Okay, this one has ratio, and you see ratio. You literally see ratio. You see two ratios. Yeah. Okay, or you see n1, n2, n2, n3 plus numbers plus numbers. How many numbers? Two numbers. Okay, two numbers. Okay, two numbers for short. So ROI as well. So you have n1, n2. Okay. You have n2, n1. Later I show you why. n2 and n3. Okay, why? Because when n1 is repeated, I will draw at the front. And then we have your n2. Okay, a mistake. This should be n2. This will be n1. Okay, then this is n3. So they'll say things like n1 is how many times of n3. Okay. Okay, I hope this is the last page. Huh? Oof. Not yet, not yet. Still have. Yeah. So we have then this is very similar to simultaneous. Okay. So for example, they have some tables and some chairs equals to so much. Then they have some tables plus some chairs equals to so much. Okay. So you have to write two equations, make opposite the same. Okay. Okay. I hope to say that this is the last one, but it's not. Okay, this is the last one. Okay, last one. I promise. This is what we call the remainder. So you see the word remaining. So it's remainder. So there are two methods. Method 1, method 2. Method 1 is pull down. So you solve upwards. Okay. And then this will be U. Then this can be parts. Okay. Oh, still have this is not the last one. I'm so sorry. Then this will be branching. We call branching. So we have that. And of course, you need to know how to handle actual fractions. Okay. Okay, I hope to squeeze the last one over here. And that is called units and parts. Okay, so units and parts, you have before ratio, you have external unequal change, and then you have after ratio. Okay, this one, you will have to draw your HDB flat. Okay, then before change after, object 1, object 2, and of course you have your parts. These are your units. That's why it's called units and parts. And then this one, you have to make the same. Then followed by your model. Okay, followed by a model. So maybe this one is the parts. Then this one will be your units. And this will be your numbers. Okay, your numbers. Okay, so to solve, use original table. This is so important. Okay. Okay, I think I'm done. Oh yeah.